the system designs in the DynamoDB. Basically, how do we able to use DynamoDB for solving our problems? So we will start with some schema design with DynamoDB, and then a technique to actually increasing the read capability, technique to increase the write capability, and then how we can rotate the data, retention management basically, and finally we will close it with a short idea about what is a transaction in DynamoDB. DynamoDB is basically a NoSQL database which is provided by AWS, and NoSQL is basically just a term where it means it promotes more into the eventual consistency rather than the acidity, where it means also that it has a more capability to do about increasing scaling the writes, right? It's because that was actually one of the top problems in SQL databases, where there is a easy solution to scale the reads, which is by creating read replicas, but it's pretty hard to actually increase the write scaling by scaling it horizontally, because if you try to look at older designs in top companies like Slack, and if I'm not wrong, Facebook also do that, how they actually scale that right for their SQL database is they need to create another layer on top of the SQL databases to actually do the proper partitionings of data, sharding of data. So it's not that easy. While for NoSQL, it is easier to actually scale your writes, because it is by nature is what they are trying to solve actually, the horizontal scaling of the writes. That's why the consequences comes in things like eventual consistency, because horizontal scaling means that you are spreading the data between multiple hosts, and it means that you need to make all these nodes or hosts to actually have a synchronized data in order to make it consistent. That's why the eventual consistency is one of the drawbacks from the any kind of NoSQL solutions. Now we will talk specifically about DynamoDB. So first is about the basic schema design. In order to talk about the basic schema design in DynamoDB, we need to know about two things. First is partition, and secondly is sort key. So if we are talking about SQL database, we will have this primary keys and so forth, right? So partition plus sort key is actually works like the primary key. These two combinations in DynamoDB database should be unique, right? So what is the difference then? Why do they call it one is partition while the other is a sort key? Because physically behind the scene there are differences in the roles of the keys that you put as partition and those that you put as sort key. That's the reason why they don't call this all into one single name primary key, but they separate it. Partitions has the significance that your data will be stored in different hosts, potentially different hosts. Basically, it's the key that is being used by DynamoDB to determine how do they spread your data into different, potentially different nodes. So in this case, for example, it's like, imagine it like it doing some hashing. For example, if the key, an example value is ID 123, okay, and then what it means is throughout their hashing value, they will determine which node will store this, okay. which node will store this. And of course, because this is NoSQL database, usually there is also a replications to ensure that the data has a higher availability probability. Because if one node downs, if you only store it in one node, of course it will be gone. So that's one of it. Okay. Basically, that's the significance of partition. So whenever you design how you design your table in a DynamoDB, you should remember that what you put in partition means how the data will be collocated in the hardware, okay, in the nodes. Well, how about sort key? Sort key means it names as sort key because this will be indexed, it will be ordered in a certain way. That's why it's called, there is a sort term there. The one thing that is different with partition, of course, that sort key doesn't determine where in the nodes your data will be stored. So your data with the same partition, different sort key, but different sort key, those will be in the same hardware. Okay, so that's the two key differences between the partition and sort key that you need to remember. To summarize again, partitions is about have the significance on determining which nodes your data are going to be stored, while sort key is just about the sorting or the indexing of it. Now, how do we try to derive from a problem into a design, right? So in NoSQL as general, you have to remember that the way you design your table should be based on how you use it. How you use it, not how the data is logically structured. So that's the difference. When you remember your study about SQL, usually there is this thing called normalizations, BNF theory, and so forth, which is trying to make the data to be in the right relationship with each other so that it reduces duplications of data. But that's not the case in NoSQL. In NoSQL, you have to start from how you are going to access the data, how you are going to write the data and access the data. That's the most important part. And the normalization is normal. What I mean is, the normalization is the things that you are accepting in the NoSQL. So you will have duplicated data more than when you are designing an SQL. But it is essentially so to reduce the potentials to the joining. Because one of the things that recurringly bringing down the performance of an SQL database is actually join operations. Join operation is pretty expensive. That's and seemingly so more so in the SQL. If you try to separate, actually it's almost impossible also to do join. In a way, you can do join in NoSQL. Logically speaking, you can always reach a similar result like joining, but it will be very expensive because imagine that the data will be spread across different nodes, right? So if you try to create a design of data where you need to join the data in NoSQL, especially in what you call it, DynamoDB, it means you need to scan a lot of data because joining means you have to search for the keys that is joining the two different tables, right? So once you got this, you have to retrieve the key and then using it to actually search this one also, and then combining the things, joining the things, and then the join will not always be one-to-one. So that's a two-step process, and the same within the SQL. It is basically an expensive things to do. So avoid to do join and try to be comfortable with the normalization, duplicating data. Let's try to make an examples. For example, if we have a chat applications one-on-one, how do we going to design the data? Okay, so in this problem case, we need to start from how do we going to access the data. The data access will be one of the core data access will be when the user open up their chat messaging between he or she with her friend, for example. Then the application, the client app, will retrieve the list of the history message from the database if it doesn't have it yet, and that would be based on the reason, right? The reason messages, because when you open, of course, you want to start from what was the recent things that you've talked with the other person, not starting from the old one. So in such case, you can see that there is an order there, right? An order. What is the candidate for the order? It could be timestamp. Okay. Basically, we need some sort of order. Another thing is, how do we define that these messages are the messages between, let's say, Alice and Bob? It means we need the user ID between Alice and Bob. All right. So this is user ID 1 and user ID 2. So these are some candidates, okay? Candidates to actually retrieve the data. Essentially, if we know these combinations of the user IDs and we know the timestamp, we can retrieve the recent messages to be populated into the chatting application. Now, this is our initial candidates, but we can do better. So, for example, is timestamp a good thing to use? Probably so, but normally not so much, because how much of specificity that you will have to need in a timestamp. Okay, for one-to-one, actually it might still be okay to use timestamp, because if you have the specificity into millisecond and so forth, hardly thinkable that that Alice and Bob will have that kind of speed in chat, that it could be having several messages within the same microsecond, right? So timestamp might be still good, but another thing is we can do to make a unique message while not having timestamp is to create a generated ID. Okay, message ID. Why do we want a message ID instead? And this message ID though has to be ordered. So that's the key points. For one-to-one, maybe message ID, the problem with timestamp, once again, that it might not guarantee uniqueness, right? Because for each message, you need it to be unique. So in a way, one way or another, you still need a message ID. Timestamp is not that good because it's like you are relying on the fact that human will not be typing that fast enough, that the timestamp would never be clashed between the two of them, right? And that is in terms of probability, of course, that is logically makes sense, but it doesn't guarantee that it will be unique. So that's why it's better instead to actually use message ID instead of timestamp. And the message ID has to be orderable. It has to be sortable. And how to do that? One of it is actually to what do you call it? One way, of course, the more expensive one, you can use like timestamp as the initial entry as your message ID. But after that you can actually also like increase it by some prefix, incredible prefix if it is already exists before. Because remember, partition plus sort key are working like primary key. It has to be unique. What I mean by that, for example, in terms of message ID, you can make it from the timestamp 1, 2, 3, 4, for example, the timestamp. But if it is already exists, then you do another round by increasing it with some numbers until you find until you able to enter it. That's one way. Another way, of course, there is these several other techniques, like for example in Twitter, if I'm not wrong, Twitter using the design that is called snowflake design. Basically, we will assign parts of the bits as the hardware numbers, and then parts of the bits as the timestamp, and so on. And then finally another one is like the increment number or something like that. So this will sort of, if we order it correctly, maybe the hardware should be the last because we don't really have things about the hardware itself, while the timestamp and increment is the beginning. So this is like we partitioning it like this is actually many of solutions in the old days where storage is pretty limited, where you have to within a several bits you have to designate what the several first bit for, then several next for, and so forth. But essentially we have to find a way, an ID that is actually incrementable. Okay, and that's why just now for the sort key, instead of using timestamp, we chose to use artificially generated ID. Okay, now about the partition. Of course, we want all the chat for Alice and Bob within the same node, so that all the sort key later on is easily retrievable from there, right? Now, what is the problem if we just directly use user ID? Now the problem is who from the Alice and Bob become the ID 1 and who become the ID 2, because this is a reciprocated situation, right? Where Alice and Bob are actually on the, let's say, on the side of Alice, it could be Alice become user ID 1, Bob become user ID 2. The reverse also possible. Then when Alice open up their app, when Bob open up their app, how do they know which one of them is the user ID 1 and which one of them is the user ID 2? Way to do this, of course, is that we need another table that is managing the basic metadata of the messaging channel itself. And that channel, that table, why? The channel will have channel ID, user ID 1, and user ID 2. Okay. So when a channel created, it will create a channel ID and that channel ID will be attached into the list of what Alice and Bob has. So this channel ID is a shared number between Alice and Bob. Even so, if later on we have a group chat, we might not need to do this. We can do this user IDs, and the channel ID will be stored, of course, in the Alice and Bob ownership, right? Like, for example, we have another table which is user channels, which has user ID and channel ID. Okay, so we need to have something artificial called channel ID instead of user ID and user ID 1 and ID 2 as our messaging table design. Okay, so this is messages table, and for the partition key it will be the channel ID. So that is an example of how we can design a basic design in DynamoDB for a case in chat application message table. To summarize things, we were starting from the initial candidate, like how do we going to read the data to populate it into the application, where we need something in order, we want to order it from recency. The first candidate was a timestamp, and another thing is we need to know that as much as possible the communication between Alice and Bob should be placed in the same node, and the first candidate was user ID 1 and user ID 2. Then timestamp was replaced with message ID because timestamp doesn't guarantee exactly what is no collisions at all. So collisions will comes up, and when collisions comes up, we need to make sure we can handle it. That's why we have this term called message ID. Something like message ID. This message ID basically can be created from timestamp, and then whenever it failed to be entered the data, we know that it was because there was a primary keys already with the same values. That's when we increase it with some artificially incremented numbers until we can what could populate the message into the database. So that's how timestamp was evolved into message ID in our design as the sort key. Now for the partition key, user IDs is evolved into channel ID by having it to be, because we don't know, it will be hard to understand which one become the first user, which one become the second users. That's why an intermediate ID called channel ID to be shared the same way between Alice and Bob is important, and that could be coming up from a different table to store the channel ID and the users involved in it, and the other way around, right? So in this case, that's how we use channel ID and message ID there. Of course, another way, that would be one way to actually, if you know, to have our message table generated. Now, how about the channel itself? All right, the channel itself. Let's say we can have this is one of the design channel ID. Of course, this become a partition key. Right? The partition key. Then do we need any what you call it? Do we need any sort key? It depends really. If the channel later on going to be evolved into a group channel also, right? then it will be difficult. It's not really difficult. It's more about how to optimize between storing everything here as the user IDs and so on, and the user channel. So that's why we need to think about how does channels going to be accessed. Of course, let's now think about us as the users, the client app. And the client app, one of the first things we will render is actually the list of channels that we have, the communication. For example, Alice talk with Bob, that's one channel. Alice talk with Jane, that's another channel, right? So when Alice open their app, Alice will look at all the channels that she wanna have, and in that case, user channels will have user ID, channel ID, and all the channel informations that the channel have. That's one of the way it could be. Another way, though, for that one is that we need to understand also the pricing model. Okay, so is the pricing model based on the numbers of rows of data or the size of the data? Because if we design it this way, that one row of data is a different channel name and so forth, this actually means that we will read more rows, right? But if we design it differently, for example, if we design it channel IDs or channels, and then the channels will be a list of JSONs that the channel have, that's another different things that we can also store it, and that will make us having to retrieve less rows, but of course one row will have a lot more data than usual. Right? So these are the things that we need to check about the pricing. If the pricing is based on the size of data rather than the number of rows, it in my opinion, we better go with this design because it is more tidy, it is more structured, and also it is more tidy and more structured. And usually because usually per row there will be a limitations of the size of data that can be stored per row, right? While for this one, for this design, it will be more efficient if you are actually being charged, if the pricing is being charged per row of data. If I'm not wrong, DynamoDB is actually charged based on the size of the data, while for example, if I'm not wrong, Google Firebase charge per row of data that you retrieve. So in that case, you need to also care about the pricings, whether you want to merge it as much as possible within a row or you want to spread it out. So if you notice here, if we make these user channels with this channel name, and for example, what you do in it, of course, channel and channel name, that's it. Channel name can be created if it is one-on-one, Alice and Bob, and so forth. If it is a group name, of course, the group name of the, if it is a group chat, of course, the group name of the group chat. So if you notice, channel name here will be duplicated many times, right? Because when we store for Alice, Alice and Bob will share the same channel ID and the same channel name. And hence, this channel name and channel ID will be duplicated a lot. And for this case, user ID will be the partition key. And for the sort key, potentially is this. or we can go away without sort key if we doesn't really care about sorting. But of course it's better to have a sort key in terms of the channel ID, because we can open up with thousands of chatting, and we don't want to, for example, we don't want to have it such that well, we need this channel ID because that's determine the uniqueness of the user channels anyway. And also we need it to be sorted because we want to, as much as possible, keep the consistency of how the channel being rendered when the user open their applications. Right? So this is an example of the normalization. We also talk about an example of how to convert a messaging table, how to design a messaging table in the DynamoDB. So that's the basic schema design with an example, use case examples of it. The next things we will talk about later on will be a technique to what are the things we can do to actually increase the read capacity of DynamoDB. I think it's best if we have it in a different video, because for now we have a lot to already, which is about what is partition key, what is sort key, how it affected in in how the hardware store it, and how do, in this example problem, we try to design a message table, and then how we also design the user channels here, and two potential designs, which is this is actually extended towards if you have a different NoSQL database with different kind of pricing model. But for DynamoDB, you will use this one. For example, if you use Firebase, you might want to use this one to reduce the cost of your database. So that's it. In this design, we design based on how the hardware is being created, and secondly, how the pricing model is being used. And we also give an example of why duplication is preferred here in the NoSQL database rather than normalizing it, because look at these user channels. When we are okay with duplication, in this case the channel name and channel ID will be duplicated, of course, and channel name will be duplicated a lot, and we still keep it in the same table, because if we do this, then for each user, when Alice open their app, they only need to make one API calls to read the user channel one time, and then she has enough already the data to populate to render the applications, the channel list. Same with Bob. Imagine if we separate it, normalize it with another, for example, instead of having the channel name here, we only have the channel name in the channel, in the channel table. If this is what happened, the problem with this is the fact that now when Alice open up their app, she need to query to database, make a two API calls. So the cost will be doubled already, right? It will be doubled already for the cost, because now you have to call to different API. Of course, there is these things about the size of the database and so on, but usually when it is already two different API call, it will be more expensive. Another thing is the latency will be higher, because now it become two API calls rather than one table calls. So that's it about the basic schema design. In the next video, we'll talk about how to increase the read capability, how to increase the write capability, and so forth. Okay. Thank you for watching. Give a like if this is valuable for you. Bye.